Welcome to Technology Tangents. We get leaders together to discuss the important tech of today and the implications for tomorrow. Our discussions are fun, lighthearted, and frankly opinionated, but hopefully gives you a sense of what matters, what to pay attention to, and what to ignore. Jason Goth, our resident CTO, how are you this afternoon?
I'm great.
Well played. Yeah, and our new CEO, North America CEO. Welcome, Kevin. How are you today?
I am well. I just want to say to all our listeners, I'm the person to ignore. So just went back to the intro, but I'm doing well.
So you have the right job then. That's exactly, you got the right title to not justify us ignoring you.
Yeah, that's great.
It's perfect. Yeah. Everything aligned. The stars do align sometimes.
Yeah. It was happening before, but now you know why.
Okay, well, let's dive in, shall we? I want to start off with the Google's latest announcements on Gen AI. Gemini 2.0 is released as of December 11th. It is their latest iteration of the Gemini model. Of course, it's a large language model for those of you who are watching. Their latest version, it has some new features in it, some multimodal features, outputs, inputs, auto generation. It's designed to perform tasks a bit more independently than the previous versions and have a bit more of that decision making like we saw in 01. Jason, thoughts on that? Anything worth just off the top of your cuff before we dive into the details of the other things they announced?
Well, it can't be worse than the first version. I'll say that. I haven't had too much chance to get into it because it's in beta and we're not really able to get a full access to it yet. But the model, I'm sure it's great. I'm sure it's much better and multimodal, and some of the benchmarks look like it performs really well. But I think they've really taken a much bigger scope, in terms of this. And it's not just the model that they're releasing. There's a lot of other components that are, releasing or announced to release with the model. And I think some of those are a little more exciting to me, a little more interesting to me. There's, they've got a notebook product, really,
Notebook LM.
Yeah, Notebook LM, which would go with it, which would allow people to use it, have more of a user interface to the model, similar to ChatGPT, but much more kind of Python notebook focused for more, you could do research tasks, embed different things. That's interesting as an end user tool to make it easier to access the model.
My favorite thing is the people who use that now to write podcasts from start to finish, effectively using Notebook LM to here's all the data, here are all the articles I've seen, here's all of the great stuff that's interesting, shove it in there, upload all of that, and then say, hey, write me a podcast, and then it does the voice synthesizing as well, which is pretty impressive. So soon, you won't have to look at me anymore. You'll have a much better host.
Much better host.
Yeah, exactly.
Yeah. But the other thing,
or is it Memorex?
Nice.
There's a lot of people listening that will have to not know what that means, but
they can go use Google Gemini to ask.
Exactly. But there's, Flash is supposed to be a developer-focused model for development and testing, so that's faster and easier to use. The problem with using some of the smaller models for just testing and development is that they don't perform very well, and so you don't really see the same behavior when you move from development to production. And so supposedly, right, again, all of this is through announcement and demo and early access beta or alpha that is being reported, but that it performs as well as many of the larger models for development purposes. But then there's Mariner, which is like a next gen browser. Essentially, from what I've read and researched about it, it actually looks at the pixels like a person would, right? As opposed to parsing markup. And, that allows it to see things like images and relative position on the page and some of that kind of thing. And then the agents, right? There's Astro is a component that is an agent that is multimodal, that can, look at, and again, reported to look at the maps and lens and other things.
Astro, by the way, has the best demo video. If you haven't seen this yet, it's amazing. Basically, a woman walks through the office, is talking on her phone, like points at random stuff, like, hey, what is this? And it's like, oh, that's the tweeter of a speaker. Give me an alliteration about pens, for example, and it does. And she goes up to somebody a screen and they're coding something like, what does this part of the function do? And it describes that. And she switches on to some glasses, just typical glasses that you're wearing, and continues to walk around and do whatever. ask questions about where do you think I am, London's Cross, things that are kind of cool. But then she's like, hey, where did I leave my keys? Did you see them? And I actually have to like parse all that video and be like, oh yeah, they're over on the desk over here. Like it was a really cool demo video. Now how real is all that? We'll see, but it was a really cool demo video for sure.
Yeah. And then Jules is like a set of agents for developers. And so they've, the long story short is I think they have embraced this idea of agents and let's have lots of, smaller functions or agents that we stitch together, and we use the LLMs to figure out which ones to run, and these kind of, the term that we use for this agentic workflows, right? But, and I think, what we see in how a lot of these technologies actually get deployed in clients where they're useful. I mean, lots of them get deployed, not many of them are useful, but the ones that are useful tend to adopt some of these more agentic type of approaches. There's other products out there that do that independent of the model, but I think Google's really seen that and embraced that. And again, a lot of these things turn into leapfrogs, right? Someone releases one, someone releases a better one. And I think they've tried not to release just a better model this time, and really thought about a lot of the, like our, as we would advise in our talks and our books around, in our papers around thinking about how these things are used and designing it from the end user backwards. I think they've done that. And so they have a lot more of these components, which are really wrappers or ways to use the LLM, not just the LLM itself. And so it's interesting. I think that's the right direction. I think that a lot of people are going to have to pivot because of that. It will be interesting to see, can you use those things wholly? Are there still places for these other frameworks like, LangChain or Crew or whatever? Which again, I think we'll probably have a combination of both, but I think the other, LLM providers will have to react to this kind of pivot in direction. And so, really interested to get my hands on it and really, start trying it out in some real world settings.
Yeah, that makes sense. And I think, from my standpoint, because like I told you guys when I was at that All-In Summit, Sergey was there. He was talking about how much he's leaning into this exact space right now. And we're seeing, I think, some of the fruits of that early work. I think for me, the big thing is we're getting to a place where this really, 2025 in particular, will be really the year where these systems actually hit production. And what I mean by that is, Gemini 2.0 with the multimodal, the seamless integration with audio, it really means that we can actually have it do things for us with the integration of reading web pages, for example. It goes back to this point we talked about before. The blocker on Alexa, on Siri, on these sort of original chatbot personal assistants was that every single website, every single e-commerce player had to actually build an agent, a bot, that would interact with that. They had to build an app in the App Store that would work with that particular platform. What's so different in my mind at this generation is that none of that's required. If the models are good enough, they already have everything they need to do everything on your behalf, because we do it on a computer to begin with. We're not calling people. But even if they had to call people, they can. Like book you at a reservation at a restaurant. Like they can call and speak. They can book your airline ticket. They can look at, what do the rooms look like in that hotel? Is that good? Is it bad? And make the right choice for you. And so I think that's really what we're going to see in 2025 in particular, is these things continuing to progress, get a little bit more mature, but most importantly, actually drive real value for the end user. It'll really be this point when we start having these agents in everyday life. And I think that Google is well ahead on that anyway, from at least their release cadence here. It seems like this really does mark the shift from that assistance to real autonomy. And how good they are, we'll find out soon, I suppose.
Yeah. The other thing I thought was really interesting in looking at all the early documentation is, I mean, it almost became comical in that every page mentioned about how and we will not incorporate, your data for training, and we'll keep your data private and separate. I think they've gotten the message from the market loud and clear that no one wants, their data incorporated in training. Mm-hmm. Because that is, I mean, it was, again, almost comical that how front and center that was in all the messaging.
Yeah, that is a really interesting point. And I think the other part here, and this is where it's a bit of an interesting debate, as these models continue to get better, the question is, what is the next required element to make them even better? Meaning that Grok is now the largest model we have, or excuse me, Gemini is the largest model we have in production. Grok, though, is right around the corner. A release in Q1 is promised. Remember that Grok is the one that XAI, Elon Musk, he created this company out based off Twitter. It has all of the Twitter data and just everything else that will be released coming up. He's building that with the world's largest GPU supercomputer ever created. And by the way, I say ever created, I mean, it was well established in academia and among experts that you could not build a system this large. We're talking about 100,000 NVIDIA H100s that are linked together that are used for training this model. The backbone of just how do you transfer data across these chips was previously thought to be impossible to keep them well fed effectively with data. Turns out he did it in a very Elon Musk fashion of just making it work in 120 days or something incredibly fast. He had to build a whole new Ethernet protocol. He had to build a whole new backbone. He had to build an insane amount of things that really revolutionized what's possible. But now he has 100,000 GPUs running at full bore, training the next generation of their model. That machine, by the way, is called Colossus.
That was pretty amazing. I saw that. It's like, well, Ethernet is not that fast and the switches are not that fast. Like, well, we'll build our own switches and our own version of Ethernet that strips out and everything. I mean,
all the error handling, all of the protocols for just gone, delete. Very Elon Musk in that way. And again, just like
would not advise our clients to write their own networking protocols, but
that's usually end well.
No.
Yeah, but again, like in this way, he has achieved what was previously thought to be literally impossible. He took his first principles, show me the physics that says this is impossible, and nobody could. And sure enough, it's not impossible. He's done it. And by the way, this is just phase one of it, right? This is half the size that's going to be required. He planned on doubling this to 200,000 GPUs.
Is that going to be used to get rid of the deficit, or is it?
Well, he has spent the estimated cost that I came across from HPC Wire, and again, seems reasonable. They're high compute. They probably know what they're talking about $3 to $4 billion is what they expect this machine cost him to build. And again, he did it like in 6 months. This is just incredible. Like the math on this is staggering and so surprising. Mm-hmm. The other thing that's fascinating on this, really from my standpoint, is the actual amount of power that it consumes. So if you just think about, it's built in Tennessee. The original proposal that the Tennessee Valley Authority was provided was about 8 megawatts of power. It's now, the later was increased to 50, and it ended up being 93. So 93 megawatts of power for this one computer that has to be consumed. It is a staggering number, frankly. If you think about just a typical power plant, like, think like a fossil fuel coal fire. We're talking about like 500 megawatts of power.
Yeah, I was about to say it's pretty much a third of a good sized data center. Right,
exactly. We're talking about, it suddenly becomes really clear why one computer that one company is using by themselves in its totality, it suddenly becomes very clear why Microsoft is buying entire power plants, nuclear facilities that produce, like 1,000 to 1,500 megawatts. It's because they really need that much power, which I think has a lot of really fascinating second order effects and tag on things that'll come from that. But this power consumption, I think, is going to be a giant deal as we move forward in this space.
Not to change topics off power, if you wanted to get onto power consumption, but
wait, I wasn't done.
Oh, okay.
Let me one more thing. I got distracted by the power thing. Sorry about that. So my point in that is so he's built this new supercomputer, this Colossus, way more compute than anything ever before. Here's the question that people are then debating. Is it more compute that is needed to make this next generation of models better, or is it more data? Because back to the point, you're seeing people make these claims, we're not going to use your data to train the model. Well, that implies that they believe the next thing that they really need is more compute, not more data, in order to make the models better. Or that the data they're going to get back from you using this model is not adequate enough to base any next generation sort of changes to. I think that's a really interesting question. I don't think there is a clear answer. It could be more data, although we're about out of data. So if that's really the case, then we're not going to see much progression on these models. We're at our limit on that. If it's really more compute, then we have a long ways to go as Elon continues to push those boundaries.
Well, that's kind of where I was going, but in a different dimension, which is, do we need more bigger models or many more smaller kind of we talked about this a few podcasts ago. Are we going to have like very small purpose driven models, purpose design models that then are stitched together, or do we build like these big massive models that try to do everything, right? And modular versus monolith, right? To use that term, it seems that, X and Grok has taken the opposite of the Google approach, right?
That's right.
Which is, and maybe not, maybe it's a combination of both. We have lots of point solutions and we have ever growing bigger and bigger models to coordinate them, or fill in the gaps, I guess, and move things around. It's going to be really interesting. It's one of those things I don't think anybody really knows. It's going to be more empirically driven, I think.
I mean, people have opinions, though, to be clear.
I mean, sure.
So like the chief scientist, former chief
people have opinions about like the models would never be more than this big, true. Too. So
yeah, but so in fairness, so the chief scientist or former chief scientist of OpenAI, Ilya Sutskever. Okay, Sutskever. I'll never get it right. It's okay. I don't speak Russian, so whatever. He says that the models we're done. That's as good as they're ever going to get. Is basically his point today. He says, look. What he believes they need is, he's a sharp guy. He's obviously the founder of a lot of this foundational models. He believes like data is the biggest blocker. It's not compute anymore, it's data. And insofar as it's taken us all of the time of history to capture the amount of knowledge that we have today written in digital form, we're not going to change that very quickly. And so his perspective is like, this is it. This is as good as they get. Relax. On the flip, you have people like Elon who are saying, like, show me the math, show me the physics that prevents us from extracting more knowledge from what we already have. I mean, I do believe that we have not. So if you look at how these models are trained, they're trained off the corpus of the internet. We've all read the internet. It's not exactly the best data source in general. It's kind of garbage. They have a bunch of processes to clean it up and to really isolate the pieces that are really good and bad. But I think that if we just take a lesson learned from computer vision models, Andrew Ng spent obviously a long time working on these models specifically, and what he realized is the models were adequately good, so aligns with what Ilya says. However, the data quality was the biggest blocker. We didn't need more of an evolution in computer vision models themselves. We needed evolution in how we label the data these models are trained on. So my gut tells me that it's somewhere in between the two, like just more compute's not going to solve it. More data would help, but what you really need is more clean data mixed with better models. That's my intuition.
I think that you're probably right. Although I think probably I lean more towards the compute side, just because I think there are a lot of sources that that it is not feasible to include in a short amount of time. It's not that we don't have, like we're going to have a bunch more data. It's that we can process the data we have in a much shorter time period. And as data continues to get created and grow, especially language data, through YouTube or whatever, it's going to allow you to iterate faster. So I tend to follow the compute side, but I think that it's a somewhat orthogonal access to say, to have big or small models and stitch them together. Well, either one, either the big ones or the small ones, how do you make them better? Is it more data or more compute? So they're somewhat orthogonal concerns. But I think those are all the questions in research. But, back to what's the purpose of this pod, right? And it's to help companies. Like I think that's in a way more of a research problem for Google and X and Meta and all the people in OpenAI.
But I think it matters, right? If you're a decision maker today, you're a CIO, CTO today, or a CEO saying, hey, is this the time that I lean in? And how do I lean in? Do I lean into the approach where we say, look, we're just waiting for the really big model to come out and it will solve all the problems? Or do I lean into let's just go get point solutions everywhere and assume that we have an entire corpus of point solutions? I think those are sort of distinct options that people could pursue. And so in some sense it matters. If you really believe there will be one model to rule them all, maybe just get the foundational pieces ready, assuming that world If you say, no, that'll never work, we actually have to have a bunch of agents to solve very bespoke point solutions, then you might as well get started with those point solutions today and just build them out from start to finish.
No. I'm talking about the power, is it more compute we have that we need to train or more data? Like most companies are just consuming what's available on the market, right? From OpenAI, from Google, from wherever. I still think my answer to that problem or that question would be, it depends on what your problem is, and let's validate empirically, is the big one perform better, stitching some smaller ones perform better, but start with whatever your problem is. Let's figure out the right solution for that. But how the research organizations continue to grow and improve those, I don't think companies need to wait till that's figured out, right? Just like Oracle started building databases 30 years ago, 40 years ago. There was been lots of improvements, but you want to get on those platforms and use them to get benefits of those improvements, not wait till they're perfect.
Yeah, that's fair. I think the other thing that occurs to me, though, in that decision matrix would be there are more players that seem viable today than there were a year ago. I think up until this moment in time, and I'll be blunt, like any client who asks me, which of these platforms do we need to use? How many do we need to evaluate? My answer was always the same. Let me save you a lot of work. You just need to use OpenAI. Right. It's significantly better across every dimension that matters to a business historically. Gemini might be challenging that. Again, hard to say until we can go actually test it. That might be challenging it. But if you believe compute really is the blocker, then I think Grok, which I've paid zero attention to, if I'm being honest, might actually be a dominant player here. Because look, they did something that people thought was literally impossible. So Google, Microsoft, AWS, OpenAI, they're all caught very flat-footed. Nobody was investing on building a cluster of this size because they thought it was literally impossible. So what kind of lead time does Grok have? Well, at least 6 months, because Elon did it in 6 months. Realistically, he moves in a way that most organizations would be... they're very uncomfortable moving in the ways he typically moves. So it's probably like a year head start. And if he really does double it again in that time period, I mean, it might be that Grok is the dominant player for the next 3 to 5 years. I don't know. So I think that's where the other part that is worth considering is that this player that I thought was a nothing burger effectively might actually be a huge change in the ecosystem.
I think the tyranny of choice kind of discussion is really valid. I was looking at NVIDIA, and NVIDIA has their products out, and they've got a really interesting approach where they just package up really optimized. They take the models and build some inference on top of them, package them up in containers that are highly optimized for NVIDIA chips, obviously, and then deploy them out. And you can deploy them out to your own infrastructure as containers. But I was just looking, and I mean, I met with some folks from NVIDIA, I don't know, maybe a month ago, and they had like 3 or 4, and I went and looked today. They call them NIMs, like these little, self-contained, containers with models in them, and they have hundreds in there, and they have one's geared towards biology, one's geared in healthcare, one's geared towards weather. One, they're categorized. It's like a whole marketplace of them. Which again, really interesting. Okay, well now if your problem is some really deep specialized, protein or weather or whatever, maybe, you have options on the same platform with NVIDIA. So, I would throw them into the mix with those others. But yeah, it just goes to show that you are getting more and more choice. And again, to me, this is a lot like optimization, right? Like performance tuning. Like, if you performance tune a website, you set some goals, like it has to be this fast. Well, once you get it that fast, you kind of stop because you can performance tune forever, right, and it doesn't make a difference. And what are you trying to do? What are the parameters? How accurate? How fast? Et cetera. If you can get a solution working over that, okay, go with it for your business use case. And like, is someone going to launch one in 6 months that's going to be better? Yeah, well, build it so you can move to it easily, or don't. Maybe you don't need to, but you can't, I don't think companies like, that have some real problems that can be solved can afford to wait till the next better one comes out, because the next better one comes out, you'll always be waiting.
Yeah, that's fair. I think that is fair. I mean, I think that the headline for me is like, are we really entering this era of autonomous AIs ecosystems that are tools like Gemini 2.0 or Grok 2, where they begin to compete not just on intelligence, but their actual ability to make autonomous decisions and apply some judgment on our behalf. I think that's the era that we might be entering, and I think it's really fascinating, because what does it mean from a trust, from a control standpoint, when the agent itself is negotiating on your behalf? And what happens when my Grok agent is negotiating against your company's Gemini agent? Mm-hmm. Like, what does that look like?
Did you see that, Kevin, this is a technical, Kevin's like, why am I here today?
Yeah.
I just popped some popcorn. I'm enjoying the show.
I don't know, did you see that Microsoft had announced like a protocol language for like model to model? Mm-hmm. So instead of like, actually converting it back to English or whatever language, text, it took that last layer of output before text generation and then used that as input.
By the way, if we had a real like full-time dedicated producer, I'd ask to pull up the clip where we had exactly this debate where I said, like, I know, you're right. Okay, yes, where there's this interface that is just agent to agent, like it's just, there's no need to go all the way to English anymore.
Yeah, they called it droid speak, which I thought was really clever.
See, that's better marketing than I am, obviously.
Yeah.
I didn't coin the term droid speak. Droidspeak.com. Quick, is that available?
No, I thought that was
Droidspeak.
I was hoping you would remember. You said, I was hoping you would remember we argued about that, and I told you it was dumb, but
yes.
But apparently you did.
Apparently, sometimes I can see around the corner. I mean, so my question to you, Kevin, like, philosophically, economically, like, how do you imagine that playing out? Do you have any thoughts? Is that like, does it irk you? Does it excite you? This idea where agents are actually really, actual agents, like with autonomy and agency in solving things on our behalf. Any thoughts on that?
I think it's happening today already, right? Systems talk to each other, work through that. I mean, we may not call it agent to agent, maybe have more elements into that, but you think about any integrated solution that is doing rules-based, challenges. Right? Again, I know it's different technology, different approach, but I think we're already allowing that to happen today.
It's actually fair.
And so I don't think it's any different in the sense of like, of where you'd want to do that, how you'd set it up, what you work through it. Going back to the debate, but it actually ties to this question too, Vincent, is like, I'm on team point solution, partly just because I think you need to go. I mean, I think you need to start. I mean, I think just in a very simplistic, non-technical term, listening to y'all talk, like, is it Sun or is it Microsoft? Is it Apple or is it Microsoft? Is it AWS versus Azure? Like, I mean, there's always going to be competing things, and there's always going to be something better. I think to me, what gets me excited about this is thinking about the business processes, business solutions. Jason, you were talking about pain that we start to do this with, and having the wisdom to know, okay, where do we go with what we have, and we're going to continue to optimize on that. We're going to solve a problem. Where would we have something may look at it differently, but I think the concern about just waiting for the super solution, whatever we want to call that, is I think it's only going to continue to expand. I mean, I think we're going to continue to, human history continues to push against the known limits. And so, I think you have to start to use the tools and how they'll play through that. And I think if you go back to what you're trying to do, even like listening, I don't know these tools like you all do, but like when I'm listening, you guys talk about Gemini, like they're taking solutions where people go to Google today and they're making them better. Like, I'm not surprised that that's the use cases that we're using them for. And I think that will continue to persist in terms of different products that we use. What I think is interesting about what Musk is doing is like, everyone else has a place in the game, right? He's maybe got the data and those components from his different sources, but like, I'm a search, I'm a chip, I'm a hyperscaler. Like, it's going to be interesting to see where he fits into that ecosystem and how we'll view that in terms of like using that product. Because OpenAI would be like that today. They don't fit, but they've hitched themselves to different providers where they're kind of using that as their distribution channel. So I'm curious on where that happens and how he takes that problem.
They did open up API access to it directly as like a cloud service provider would. Just recently, I got access to it, and it's pretty good.
Yeah. Well, I mean, it's just like typical Elon style. Like he continues to go into these industries that are pretty closed, high-walled ecosystems and just blow them up.
Yeah.
I mean,
Rockets.
rocket, space, defense. I mean, these are things that are very difficult generally, and he seems to manage to do that. I mean, you take cars, like automotive, again, really expensive, really capital intensive, and just seems to blow it up. And it is remarkable. It's a really fascinating point, is that what will he do to these walled gardens of the FANG stocks, if you will? Yeah. Just blow them up, apparently. It's really interesting.
Your point, Kevin, around it's no different than, someone putting a bunch of rules in a rules engine today is really interesting. I was just thinking, as you said that, I'm like, my first thought was like, well, maybe if like there's like really precise exact rules that are easily specified, we should specify them in a rules engine, as opposed to letting a language model try to interpret what we want. And then I thought, wait a minute, we are using a language model today. It's the rules developer, and I'm not sure how accurate they are, right? And so
I think it was a spot on point for sure. The thing it also made me think of is, I was challenging a little bit, just like, is that really true? Like, where have we done this? Then I thought, well, shoot, do you ever go to your app and go to a restaurant, you want to get a reservation, you open table or whatever, and it's like nothing available. So what's the first thing you do? Like, that thing is negotiated on your behalf to find a reservation through some rules they've established. You call the restaurant, and the restaurant's like, oh yeah, sure, no problem. 2 for this? Yeah, absolutely, we have that open. Here you go. And so there is sort of a disconnect between this agent, if you will, this app working on my behalf, and then me doing it myself. Like, you end up with different results. And so I think it does happen today. You're right.
Spot advertising, spot markets. I mean, all that stuff is it's just a faster way to do the things that we're already doing today. Mm-hmm. Going back, not to keep going back to the point, but I am intrigued, Jason, you've been making this point for a number of times now, but thinking about who controls the keys to the kingdom, right? So you've got Microsoft solved the problem just by 3 Mile Island. So that's the power solution, but it's hard to get past what NVIDIA has as a competitive advantage, right? There'll be other chip providers, could be other elements of that, but when they're all kind of running, I mean, how could Musk build it in 6 months? It's because he stole all his chips he was buying for all his other companies, right? If he couldn't have done that, he wouldn't have been able to do that. But it is interesting, like, who really will have the constraint piece, and is that the CPU, that part of that, or what is going to be interesting on that, and then how and where do you start to use that as your competitive advantage to what you want to roll out? Because you are seeing, just like we saw in cloud over the years, you're seeing a big convergence of the different people coming at it from a slightly different competitive advantage that I think it's going to be interesting to see, where do you play together and where do they start to put up barriers? Like, again, just I'm never say just do this, like, the money, but NVIDIA says, I'm not selling you chips anymore, or something else, or how that plays out, right? So
there's another aspect to that. I think there's several other competitors or new startups that are looking to build chips, and I think Apple's building a chip, but a lot of these chips are designed for inference, right? So if you think there's generally 2 problems, there's training, which is use the GPUs to build the models from all the data. And then there's inference, which is query the models, right? And so those, inference chips, can be much smaller, much faster than in some of the big, workhorse GPUs that do that. Could they be embedded in a phone or wherever? I think, again, I don't see, and maybe, Google fabs their own silicon for training, and that's hard to do. I mean, you gotta have, there's not many, unless you're, building millions of these, things into a data center, that it makes, economic sense to sign. But I think NVIDIA will always be there. I think the question will be, on the inference side, there's another Grok G-R-O-Q instead of K, which is designing, inference chips. Apple's designing inference chips. And will those become, 2 separate markets, right? And because they can be cheaper and lower power to do the inference.
I think the thing would be ASICs could come back into play if these things become stable enough. Then you could write an ASIC, and that's what we saw happen with
I thought about that. That's a really good point of doing that. Because that would make it much faster. Wire speed
and cheaper. Yeah, everything would become a lot better. And we saw that exact thing happen every time that an ASIC came out for a specific. Yeah. Bitcoin-based cryptocurrency.
Fourier transform before that, right?
Yeah, exactly. We see a huge decrease in the market price of those particular coins, and so I think this will. It's inevitable. It seems to me. I don't exactly know how you build an ASIC. I know it's rather complicated, and they're point solutions, so it has to be a pretty stable.
Probably a model you can ask.
Yeah, exactly. But I think, so the other thing I was going to mention real quick, and again, playing off the Bitcoin thing, we saw a little bit of this before where, again, Bitcoin mining often took place before ASICs or on chains where ASICs weren't available with GPUs. They're very power intensive. We know that. There was a point when people recognized what we actually need to do is get really close to power generation, because power transmission is, the 5 to 10% loss depending on how far you have to go. And you saw all of these little ant farms or mining farms pop up all over the world, frankly, near hydroelectric or near solar or near actual generation plants.
Oil wells. Yeah.
Oil wells, exactly. So this is my point, is I think there's this opportunity where I suspect you'll start seeing these sort of microsites show up, these data centers show up right near the actual production of, for example, natural gas, wherever they're fracking natural gas and has it, like the Permian Basin, for example. There's a lot of natural gas down there. It's going to be there for 30, 40 years. Well, why not just build that power plant right there? You have to move the gas, 100 feet, and you have to move the power 100 feet, and you're good to go. Like, you've built this sort of closed ecosystem, and then you just use fiber or Starlink, as we've talked about before. Maybe you then use Starlink as the backbone. You've suddenly reduced the transmission of that entire supply chain down from hundreds or thousands of miles down to a few miles, which I think is really a fascinating idea too. And it also creates new opportunities. So if you think about many times when you're refining oil, you're digging up oil from the ground, you end up with hitting these natural gas pockets and you just have to burn it off, effectively flare it. Well, that's just because it's too expensive to lay down pipe to then take that natural gas. Nobody wants to burn it. They just have no choice. What if you just build a little small little plant right there, and you build the data center right next to that? Right. Well, I think there's an opportunity for some cool stuff.
Well, and there's just space too. That's the part, exactly. At least for like Permian Basin, for example. I mean, you're building stuff on top of something that you don't care about. But I think the other thing I would add to that, so we can obviously Texas, we think about that. I also think it's going to be interesting around. I think the Microsoft of the nuclear is really interesting too. The intersection of like really renewable with the power demand, I think, could lead us naturally back to nuclear, right? And so it's just going to be interesting just how we, kind of overlay the environmental guidelines and goals what we're having with these type of needs. And something tells me power consumption for computers will be a little bit more higher prioritized than power consumption for automobiles. And it's really an unintended positive impact if we start to use other clean type energies to be able to support
I think you're right. That's the other thing I was going to say is I think, as a client, one of the things I'd recommend, depending on the industry you're in, is think about what happens when power becomes really expensive. Because I think that's what's going to happen. Yep. I mean, yes, we're adding more renewable sources, and that's wonderful. The challenge with that is as we decrease the cost per power, demand's going to go through the roof. If you then look at the GPU requirements for power, it's going through the roof already, as we mentioned, and I don't think that's going to stop anytime soon. And so I think power will naturally go up. So really heavy energy intensive processes, I think, are going to become more expensive. And then the question is, how do you hedge against that now while you still have an opportunity? It will take time. I think we will solve it. I think we will get nuclear, for example, especially with the new administration. I think there'll be much less regulatory burden on oil and gas in general and power generation more broadly than we've seen before, but it will take time for those facilities to be stood up and get that online. So I think anything with power intensive probably takes a moment. So be careful. Hedge against that would be the headline there. And then I think, as we look towards opportunities of growth, anything in the power generation or distribution, I think there's a lot of opportunity to really change how it's done.
So this Christmas break, holiday break, you're buying land in West Texas?
That's exactly right. Yep. I'm going to buy some land, build some construction out there. That's going to be the play. But I do think I think you'll end up with these AI innovation hubs, for lack of a better word, around where the renewable energy is, where the power generation is, more broadly speaking. Because again, back to the point, it's not inference, it's not data storage, it's not random compute. These are really heavy workloads that once you get the data there, just let them run. They don't need to be high connectivity.
Mm-hmm. And they're very parallelizable and composable, right?
Yeah, and so I think these microsites, if you will be where they go train models. I don't think that's where we're going to do the actual inference. It's not where the edge compute happens. That stuff is, I think, by and large already there. It's really where we do the really heavy, intensive training. And the other thing, by the way, is cooling.
Yeah, I was going to say go to Canada instead of West Texas. Is what I was thinking too, that you're going to have to go someplace where you can get the same resources, but without that issue.
That's right. And so again, the cooling, is that the ocean? Do you do it with water cooling from the ocean? Maybe that's helpful. Maybe you just use traditional HVAC systems that adds more to the power side, but like the math could work out in that same way. And so I think there are these opportunities where, by the way, the other thing that I think that came up today in our workshop that's kind of fascinating, just an aside real quick, is the idea that you're using all this power generation to get AI systems to help optimize something. Well, what if those AI systems are optimizing the power generation itself? So you end up with this little circle where the AI is actually making the power generation and distribution of that more effective, which then generates more power for more AI systems.
And I'll make sure that the power goes to itself versus going to the hospital next door.
Exactly right. This is where we get to the world that, things all go very, very quickly.
Why is all the power going to power my Tesla? And I cannot get my Rivian to go at all.
That's exactly right. Yeah. Well, anyway, I think there's a lot going on here. There's a lot of change. Again, my prediction headline is that next year is going to be the year that people start really understanding the impact of all of these systems we've been talking about. We've seen it across some of our clients today in pockets where like this group here really leaned in and they're starting to see some meaningful results, tens of millions of dollars generated that they didn't have before. I think this is the year where next year, 25 is the year where a lot of people start interacting with that and realize, oh, wow, there is something here. These models are not going to keep getting better, more focused. To your point earlier, I think companies are leaning in at this point. I think most of our clients have leaned in, even the kind of laggards, at least started asking the questions in the laggard space of like, well, what does this really mean? Is this what I need or not? So I think this will be a big change, more broadly speaking. Yeah. Any closing thoughts?
Yeah, not so much on this, but it's something maybe for us on the backlog. It was interesting. I think a year ago we were talking a bit around what we thought the year ahead. So I'm sure we'll do some of that stuff in January. But a year ago, I think we were concerned a lot more around regulatory concerns, and I would say that probably hasn't happened as much this year as maybe we were thinking. So my thought is around that same thing. Like if it's pure entrepreneurial, as we were talking in a world where you have companies and organizations that are able to make their best decision how they work through it. Where do the constraints come in, whether it be power or chip or this or data or government? And I think that's going to be really interesting too. Whereas I would have not thought, so my reflection was, I would have thought more interference that I don't think has come as much, at least in my my vantage point of that. And I'm curious what that will be in years ahead or the next year, and how we continue to think through this, where we throttle just based on non-business or scientific means, just for other reasons.
Yeah,
throttle is what I meant, not throttle. But
yeah. I mean, we might disagree slightly on how much regulation was tried to push through this year, but we had
talking about our company, or are we talking about
Yeah. No, I mean, we had the Biden executive order. It did say that you're going to have to do a bunch of stuff that's going to require you interacting with 30 different agencies within the government. That stuff hasn't hit yet, in fairness. I do think, though, that, with new administration, I don't think we're going to have much of that.
But it's slow progress, at least in my opinion, this
year.
Fair.
Yeah, I think that's right. Yeah, I think the groundwork was laid, though. I think very strongly laid that we'll have a big burden. And I think it'll be interesting to watch as, David Sachs, for example, is now the AI czar on these things on the Science Advisory Committee. So we'll see what happens there. I can tell you he's not big on big regulatory challenges. When we got acquired by Microsoft back in the day, there were many words to be had about just how slow and bureaucratic that company was, let alone the U.S. government. So my guess is that will be a lesser burden.
Delete.
Exactly. Yeah, coupled with Elon on that for sure. Just delete everything. With that, for all of you who are listening and would like to learn more, please visit the Insights page at Credera.com. Thanks for listening, and I hope you'll join us again. Bye-bye.